Hello, this is Scholar doing some math today in geometry. We're going to be looking at performing similarity transformations. Now, if you remember, a transformation is an operation that moves or changes a geometric figure to produce a new figure. A dilation is a transformation that stretches or shrinks the original figure to create a similar figure. The figures will not be congruent. Otherwise, it will not be a dilation. The center of dilation is a figure that is reduced or enlarged with respect to a fixed point, called the center of dilation. For today, we're just going to use the origin as the center of the dilation. Function coordinate notation for dilation. So to describe a dilation with respect to the origin, we say x comma y, so that's our original object, and then the arrow means we transform it into kx comma ky. And basically the k is our dilation. It's a reduction if k is between 0 and 1, and it's a stretch if k is greater than 1. So let's do some examples. Figure ABCD has vertices 2, 0, 6, negative 4, 8, 2, and D is 6, comma 4. Six, 7, 8, 2, 6, negative 4, 2, 0. Alright. So this is our original object here. And then I'm going to go ahead and change colors. Sketch the dilation of ABCD using a scale factor of 1/2. So our scale factor is k is 1/2. So we're going to change all our x comma y values and take 1/2. So it's not too bad. So we take a, which is 2 comma 0, and then the transformation is we're going to take half. So 1/2 of 2 is 1, and 1/2 of 0 is 1. So let's mark that. And I'm going to call this A prime. So we start out with A, and then after the transformation it becomes A prime. B, let's do that again. B is 6 comma negative 4. So we're going to take half of 6, which is 3. Half of the y value, which is negative 4. Half of negative 4 is negative 2. We call that B prime. So 3 comma negative 2. C, which is 8 comma 2, becomes, so I'm taking half of the x value, which is 4, half of the y value, which is 1, so 4 comma 1. And then D, 6 comma 4, half of 6 is 3, half of 4 is 2. And then there is our figure. Alright, let's do it in a different one. Triangle has vertices that. The image of ABC after dilation with a scale factor 2 is triangle DEF. Okay? sketch the two triangles, verify that the triangles are similar. Okay. So let's use black as the original. A is 2 is -1. B is 4, comma, -1. And C is 4, comma, 2. Okay. So bam, bam, bam. Very small. And let's make blue this time. So it looks like we're enlarging because our scale factor is bigger than 1. So scale factor of 2 means I'm going to take 2, comma, -1, and then I'm multiplying by 2. So 2 times 2 is 4, 2 times -1 is -2. And B, so this is, they call this D. And then E, 4, comma, -1. We'll times that by 2 to get E, which is 8, comma, -2. And then C, 4, comma, 2 becomes 8, comma, 4. And that'll be F. Okay, so there's our two triangles. Now we need to verify that the triangles are similar. So remember, to prove that how triangles are similar is that all the angles need to be the same. And all the corresponding sides are the same. So we can do this multiple ways, but we're going to do this an easier way. We're going to use something that we learned from one of our other sections. So we know that those two are perpendicular, so they form right angles. So those angles are the same. And if we compare the bottom sides, so AB and DE, we get, so the length is 2 to 4. That is 1/2. And if we can compare the right sides, which is BC and EF, so the length of B to C is 3, and the length of E to F is 6, and that equals 1/2. So by SAS similarity, because their sides are proportional, and the included angle is the same, these two triangles are similar. Alright, checkpoint 1. Sketch both triangles, okay? So BCD, B is -1, -1, 0 is, or C is 0, 1, and D is 1, 0. This is really tiny. Boom, boom, boom. And then we're going to enlarge this by a factor of 4. So -1, 1 becomes -4, 4. 0, 1 becomes 0, 4. And 1, 0 becomes 4, 0. This is L, this is M, this is N. So -4, oops, Oh, it's -1, -1. There we go. So that'll be -4, -4. There we go. 0, 4, and 4, 0. And that's it. You are shrinking a photo to make a photo magnet. So the original photo is an 8-inch by 10-inch. The photo magnet will be 2.8-inch by 3.5-inch. What is the scale factor of the reduction? Okay. So I'm just going to take one pair of numbers, 3.5 over 10. I guess this would be the width. And this would become 7 over 20. And just to make sure, we're going to check 2.8 by 8. And that is also the same thing as 7 over 20. And that's something that you can use in your calculator, if you don't believe me. So yeah, the scale factor is 7 over 20. The magnet will, or the photo will be reduced the magnet will be 7/20ths of the photo. What is the scale factor if your original photo is 4 by 5? Okay, so same thing, we can do 2.8 over 4, or we can do 3.5 over 5. This would be 7 over 10. And this is also 7 over 10. You want to create a quadrilateral JKLM that is similar to PQRS. What are the coordinates of M? So use X, Y to see if JKL are dilations of PQR. Okay. So let's look at P. P is 0, 3. Oops. And its corresponding point then becomes 0, 6. So we know that doubled. Let's make sure. Because 0 times 2 is 0, and 3 times 2 is 6. Q, that's 2, 2. And K, this is J, this is K. That became 4, 4. So that is indeed times 2. R is 2, 0. So I'm just comparing the two coordinates here after its transformation. This is L. Now they want us to find M. So S, which is at 5, 5. So we're going to double it. 5 times 2 is 10, and 5 times 2 is 10. So my point M is 10, 10, which would be 2, 3, 4, 5, 6, 7, 8, 9 outside. 2, 3, 4, 5, 6, 7, 8, 9, 10. So somewhere out here. And then we connect this here and that. And there is our figure. Hopefully this helped you out. Have a good day.